All right, so here I have number 10 from the latest Webassign. The instructions say to find solutions of the equation that are in the interval. I'm just going to write this as a reminder, 0 to 2 pi. So thinking about that in terms of unit circle, this is 0 right here. If I go all the way around, I hit 2 pi. So I want any answer that's once around the unit circle, okay? Or if you're thinking about it like a graph, there's 0, there's 2 pi. I want any answer in that range, in that interval, okay? So I'm probably expecting multiple answers, and they say put them in a comma-separated list. Okay. You'll notice the way I've written this equation, 6 minus 24, cosine squared t equals 0. Cosine of t I've got in red. And the reason for this is this problem combines both trig and algebra. So I wanted to make really obvious what we were doing in terms of the algebra. The algebra is going to happen first, and normally if you can do algebra before trig, it will make your trig easier. So the algebra we want to do is to isolate cosine of t, get everything in red all by itself, the same way you would isolate a variable, except I'm isolating this expression, cosine of t. So that means I need to move the 6, the negative 24, and the squared. I need to undo all those operations. So let's start with that, right? Think about if that was just one variable. What would you do first? Well, you'd move away the furthest thing from that variable, which is the 6. So subtract 6 from both sides. 6 minus 6, those cancel. On the left-hand side, I'm left with negative 24 cosine squared t. And on the right-hand side, 0 minus 6 is negative 6. All right, now I'm still trying to isolate the trig. Undo this negative 24. But you notice what's happening between the negative 24 and the next term is multiplication. It's negative 24 times cosine. So undo with division. So negative 24 is cancel. On the left-hand side, cosine squared t is left. On the right-hand side, negative over negative is a positive. 6 divided by 24 is 1/4. Yes, you could write 0.25, but it's actually going to be easier to deal with the fraction here because on the next step, the one we're at right now, I need to undo the square. Let me get my other color here just for emphasis. The inverse, or the opposite, what undoes a square is a square root. So I'm going to take the square root of the left side and also the square root of the right-hand side. So the left-hand side, the square and the square root cancel. And you'll notice I have my trig function isolated. On the right-hand side, be very careful here. When you actively apply a square root to a problem, you do get two answers, plus and minus. And the square root of the numerator is 1. The square root of the denominator is 2. It's kind of a review of some of those exponent rules, right? The square root is like a 1/2 exponent. You do the same to the top that you do to the bottom. All right, so I get these two answers, plus or minus 1/2. And that's the end of the algebra. Now I've got to use my knowledge of unit circle, maybe some SOHCAHTOA, those special triangles, and determine when is the cosine of an angle positive 1/2, or when is the cosine of an angle negative 1/2. Okay, so I'm going to break this into two separate problems right now. When is the cosine positive 1/2? When is the cosine negative 1/2? They're going to be very similar, but they're going to lead to different answers. So let's attack this two different ways. All right, so when is the cosine positive 1/2? You might remember this 1/2 as coming up from one of those special triangles. That's going to happen here too. We're going to see that triangle start to emerge. I'm going to start with my unit circle. And if I remember that cosine is the x amount on unit circle, so that's the left-right amount. So supposing that I've moved left or right, positive 1/2. Okay, well, if I'm moving positive 1/2, I've actually moved right half a unit. All right, all the way to the perimeter of the circle would be 1. That's why it's called unit circle, 1 unit. So I want to go halfway. Then I draw a triangle right here. Okay, so there's my right angle. So it's a right triangle. It's a unit circle. The radius is always 1. Hopefully we're starting to recognize this as one of those special triangles. This is a half, this is 1, this other side, which I actually don't need, but I'm going to put up here just for completeness, is square root of 3/2. So this is a 30, 60, 90 triangle. I have to talk about what angle is right here on the interior. When you're on unit circle, I'm always concerned about the interior angle. So what angle is that? Okay, well, this is a 30, 60, 90 triangle. Across from 1/2 is always 30, the smaller angle across from the smaller side. So this is a 60-degree angle, but 60 is not going to give me the right answer. And the reason is Webassign wants me to use radians. Look at how they set up their directions. Find all the angles between 0 and 2 pi. They're not talking degrees. We're not talking degrees. We're talking radians. So I have to think about 60 degrees is equal to pi over 3. There's one of my 4 answers. Okay. I gave it away. There are 4 answers. Okay. Not done with this section of the problem yet because there's another answer. When I drew this triangle, I had a choice. I am going to move right 1/2 unit because it's positive 1/2. So the units are to the right. Let me scoot that up there. And then I drew my triangle by going up. That was a choice. I could have drawn my triangle by going down and creating my right angle below the x-axis. Okay, so now this angle that they're talking about is right here, right? Positive angles measured counterclockwise from the x-axis. The reference angle, this one on the interior, is still the 60 degrees, pi over 3, but the angle that's being measured here, start at the x-axis, go counterclockwise until you hit that hypotenuse. I've got to figure out what that is. Okay, a couple ways that we could think about it. Either you've got a really good memory, maybe you're good at memorizing, I'm not, and you know this from unit circle. So how would you get it without unit circle? Or without the whole memorization of the unit circle. So the interior angle is pi over 3. Notice if I had gone all the way around, I would be at 2 pi. But I didn't make it all the way around. I'm pi over 3 radians shy of 2 pi. So all I have to do is figure out this subtraction problem, and then I can get another answer. So I need a common denominator. So 2 pi, I need to have a denominator of 3, so I can change that to a 6 pi over 3. Right, multiplying top and bottom by 3. This is 6 pi minus 1 pi, and 5 pi over 3 is another answer. So I'm just going to keep adding to my list right here. So the 5 pi over 3 answer came from that problem. All right, I'm going to do the same thing over here. Maybe I'll just run through it a little bit quicker, right? You can always pause and replay if it's too fast. Here we want cosine. Cosine is the x amount. It's the distance we go horizontal on the unit circle. When is the cosine negative 1/2? Well, negative 1/2 means I've moved left. I always go straight to the x-axis. I'm sorry, I always draw a vertical line to get to the circle. That's going to create a right angle. Then I connect and I make a triangle. Hypotenuse is always 1. This again is a 30, 60, 90 triangle. The reference angle right there is 60 degrees, but that's not the answer they're looking for, okay? They're looking for what angle is measured from the x-axis going counterclockwise, okay? So I'm going to do subtraction kind of like this one here. Notice if I took this red arc and I went all the way to the x-axis, I'd be 180 degrees. 180 degrees is pi radians. But I don't quite get there. I'm 60 degrees short. 60 degrees is pi over 3. So I'm pi over 3 radians short, and I need a common denominator, 3 pi over 3. 3 pi over 3 minus 1 pi over 3. I get an answer that's 2 pi over 3. I'm going to add that to the list. All right, just like how we had 2 versions here, we're going to have 2 versions here. Instead of drawing the triangle by going up and connecting to the circumference of the circle, I could have drawn the triangle by going down. So here, down, create the hypotenuse. This is 1, negative 1/2. This is negative root 3 over 2. Not important, but I do want you to recognize that this is one of the special triangles. There's the right angle, okay? The reference angle, which I'll draw in blue, is again 60 degrees, pi over 3, but it's not the angle that they want. They want the angle that starts counterclockwise from the x-axis until you get to the hypotenuse, okay? So notice if I had stopped at the x-axis, I'd be pi units, but I keep going. So this time I'm going to add pi over 3. This one I took away pi over 3 to get a smaller angle. This one I add pi over 3 to get a bigger angle. Common denominator, 3 pi over 3 plus 1 pi over 3 is 4 pi over 3. Okay. You might be tempted just to be like, hey, you got the answer, great, wonderful. But you know that if you see this problem on the test, I'm going to need to see all of this work to get credits. Okay, this is sort of like partial credit has pluses and minuses, right? One plus is if you make a silly error, you still get all your credits. One minus is if all you do is memorize answers, you're not going to get the credits. You have to be able to show and document your thought process. So if you have questions on any of this, please get in touch with me, replay the video, reach out to the textbook or Khan Academy, and you can get someone else's visuals. Maybe they're a little bit more professional, probably, or just someone else's language, right? But if this is not something that you can redo, maybe with slightly different numbers, maybe instead of pi over 3s, they're pi over 6s or something, make sure you keep practicing and know that I am here to help. Okay? Slightly longer problem, but hey, this is the last round of presentations, so you made it.